Oh, I think you're muted, Deshaun.
Well, there we go. Now everybody's here from all over the world. Hello from Togo. Hello from Brazil. Hello from Ireland. Welcome. It's an exciting time to be here. It's an exciting time to be a Spring developer, especially if you're on Google Cloud. Joining me is my good friend Dan and Aaron. Hi, how are you guys?
Hello. Nice to see you, and thank you for inviting us.
Hi, Deshaun. I'm doing great.
Where are you guys joining us from?
I'm in Regina, Saskatchewan, Canada. Nice and cold here, right in the middle of the country.
I'm hiding in Toronto, nice and sunny, but cold. Probably the common denominator for us.
We've got a nice little group. Yes, I'm in Kansas City, Missouri, right in the middle of America. And it could be snowing later today. Right now it's like 50 degrees, but it could snow. Who knows? Yeah, the weather is kind of fun. Yeah, I'm excited about this topic. And we've been working on some stuff outside. And it's been wonderful. And I am just excited about this. Is there anything you want to jump into before we get going? Or should I just hand it off? Are you ready?
I think we can hand it off, yeah. Unless you want to do introductions first, Dan.
Well, that's probably a good idea. Yeah. I assume everybody knows you.
Wishful thinking. I'm Dan Dobrin. I'm an architect specialized on app modernization in Google Cloud. I have the privilege of working with customers around the world on helping them migrate workloads, refactor, change, upgrade in the Google Cloud. I work with quite a number of customers on Spring. It's nice to be here. I joined the session a couple of years ago. It's nice to be here and talk about the latest and greatest, both in Spring, but also how it translates to Google Cloud.
Mm-hmm. Aaron.
And yeah, my name is Aaron Wanjala. I'm the Java developer advocate here at Google Cloud. And so that means that I'm kind of positioned between the Java community and Google Cloud, offering your feedback on what the products should be or how they should be shaped, and offering the, helping product teams to let the community know about how the products can be used and how they can be helpful to Java developers like myself. And I've had the pleasure of this last year working with Dan on a lot of native image compilation related work. And I've also done a lot of app modernization, but not to the degree that Dan has. He's really the magician in that area. So it's been great.
Fun. We're going to keep it going. Like, these are two things that are near and dear to me. The native image stuff I'm very passionate about, and app modernization. We're going to be doing that for decades, right? So, yeah, good spot to be in. Well, Dan, thank you guys for the introductions. I want to get into it. I want to see what you're doing. So I'm going to bring your stuff up on stream, and I'm going to drop off. Aaron, do you want to stay on? Or you want to drop off?
I can drop off.
All right. It's on you, Dan. Good luck.
Okay, thank you. Hello, everybody. I will take a few minutes to level set a little bit what we want to talk about, and Aaron will get you through the interesting part, which is seeing everything in action. We're developers. We believe only what we see. But first, let's set a little bit the stage. We're part of Google Cloud, and we have the opportunity to work, and it is a privilege to work with customers around the world, and many of our customers are building Spring. Java is the preeminent programming language in the enterprise, and Spring is the preeminent web framework. So we'll give you a perspective from the Google Cloud angle. So let's get into it. Google built a lot of products, and we want developer teams from our customers to build applications. We don't know exactly what applications they wish to build, but we want them to have the flexibility of the language of their choice, the web frameworks of their choice. So to this end, and we're going to keep it on the Java side today, to this end, Google provides client libraries. These are the recommended ways to access Google Cloud APIs programmatically. We have them for almost 200 services. They're kept up to date. You can use them and build the applications of your choice. Now, if we're looking at our applications, how can we make it even easier for our customers? So for Spring, the Spring Cloud GCP project makes the Spring framework a first-class citizen of the Google Cloud Platform. So we have a wide collection of libraries, which will make it easier to use the GCP platform from Spring framework applications. And you might be building web apps, event-driven applications, whatever you would like. Now, if we build Spring libraries, we also want to offer Spring Boot starters for our Google Client libraries. We have 80 of them, and the number is growing by the day. You can use them. You just add them to your POM or a Gradle file and start building applications with them. Now, if we look into the cloud, and what is one of the tenets of the cloud, we're looking at cloud economics, and we're banking on the fact that faster startup times and lower resource consumption, memory, CPU, would lead us on a path to building more cost-effective cloud instances. Now, how do customers benefit out of that? Our customers look into it from the following perspective. Effective resource management and more performant applications would allow them to allocate more funds elsewhere. Do we offer this support? How can we make this happen? When Spring Boot 3 came out, one of the main tenets was the ability to build native images, and super fast startup is on everybody's mind. Lower resource consumption is the other one, but super fast startup in environments like serverless or applications which have to restart fast are paramount. So to this end, we have taken the step of adding native image compilation support for native image compilation to all the Google Client Java client libraries. We didn't think about one or the other. Maybe you need some for the database or the Vision API or messaging. We are taking the approach of giving the flexibility to our customers to build whatever application they have in mind or whatever application they want to modernize. So we have built in support for native image compilation. This support is available since the spring of last year, and you can just enable it in your application by including a Google Cloud Libraries bill of materials. This is up to date. We're at the latest version, and then you would use the dependencies which you would like. We highlight here Firestore and Vision API and storage because you're going to see them in action in a couple of minutes. So with this application, native application support, we're always thinking about outcomes when we're building Spring Boot native images. And we're looking at 4 different aspects. One is sustainability, smaller and cheaper cloud instances. Another one is microservices. When we split up a monolith, for example, we reduce the cost in terms of resource consumption. But on the right-hand side of the screen, when we talk about compute environments, in Kubernetes, we can get faster scalability and lighter pods. But in the serverless space, instant startup is paramount. We have seen customers who have migrated applications from the Spring 2 world and Java 8 to Java 17 and Spring Boot 3, and they were starting in 30 seconds. Optimization is great, and there are many factors contributing to it. One is optimizing the environment. So Cloud Run has great features like CPU boost, and using CPU boost, for example, brought a customer's application down to a 14, 15 second startup. Then the second aspect is tuning the application. Some tuning in the application brought it down to like 5 seconds. But then building a native image for their Spring Boot application brought it down in the second range. And that was a huge factor for the adoption. Scalability for this particular customer was incredibly enhanced. Now, when we look at how we want to build this, we want to show you different aspects. So we built a serverless workshop, which would show you multiple aspects. in different services which we have. But we want to focus on one, which is built with Spring Boot 3. It's the 303, I think that's the latest one. And it will show you how to store and analyze pictures. This is the sample which Aaron will walk you through. And it's a simple application which will pick up some images from Cloud Store, validate that it's a safe image with the Vision API, then write metadata into Firestore. When we work on all of these applications, on all our libraries, we work closely with both the Spring team and with the GraalVM team, where participants in the community, we contribute as much as we can, and we benefit from this community effort. The sample today has a multi-architecture image. We have Intel and Apple M1 or M2 machines. And the first multi-architecture image provided to us was by our friendly host, Deshaun, today. So we actually use the image he provided in our sample. So without further ado, let's jump into the demo, and in the end, we will be happy to answer any questions. Just remember one thing: whatever you would like to build in the Java space, build it confidently in the Google Cloud. Thank you.
Awesome. That's great. You reminded me of something I haven't tried yet, the CPU boost on Google Cloud Run. So I think I'm going to put that on my to-do list. But this is awesome. Aaron, are you ready?
I am, yeah.
I'm going to bring your stuff up. And Dan, do you want to stay on or I'll pull you off?
I'll drop off.
And questions, ask your questions along the way. If you got questions, I will pop them up on the screen and we can get them answered right away. So feel free to answer questions for Aaron. Thanks, Dan.
Thank you.
Thank you both. Thank you, Dan, for presenting the value here of what we're talking about with native image compilation. As I said, I've done a few years of app modernization work before coming to Google Cloud, just as a software developer. And I just think it's a really important optimization to have really well in hand and understand properly when you approach an app modernization effort, because you need to know what it can offer before you take it on. So that's what we've been speaking and writing content and blogging about for the better part of a year, actually more than a year at this point. And to that effect, we've prepared this Pick a Daily Code Lab, which Dan explained briefly. And it's a little bit, we're doing this in an effort to offer a more than trivial application. So something that makes an interesting use of several cloud services. We've linked this code lab. It's self-paced. It's about an hour if you were to go through and read it and really absorb all the information. But yeah, it makes use of cloud storage, Cloud Run, the Vision API. And it runs the Cloud Vision API. If you aren't quite familiar with it, it essentially runs the images that you pass into it through a classifier and offers a set of tags, which we call labels in the app here. And then you save that as metadata, as Dan described, into you save the image into the storage bucket, and then you save the metadata into Firestore. And as I step over to the code in a few minutes here, we're going to see that we're adding something that I think is still non-trivial and non-obvious when adopting native image compilation, which is testing. Because when you're running your app on the JVM versus running it natively, some important things change, and you want to make sure that from a unit and integration test standpoint, that your app is still, you haven't changed the semantics, that it still works the same way. And so we're going to be going through that. So if you're to follow this this guide, it tells you to clone the code from the serverless photo sharing workshop, which I already have here. And there's a lot going on this repo because, as we described it, it's a microservice architecture. There are functions, there are several things, but really what we're dealing with here is the image analysis service, which is a Java service. It's a Spring service. So if you go services, image analysis, source, that's really where we're going to be focusing. And let me just step through the change that we've made today to bring in test containers. And then we'll run the test and we'll talk about what it may be like to run the test manually and in a CI/CD environment. So the main change we made was to refactor the event controller slightly to pull out the logic that was storing the actual photo and label data into Firestore into its own service to make it more easily testable and more meaningfully testable. And then we added a container tests service to actually run the integration test against the emulator. And once we had, in order to enable that, we needed to add the test container dependency with the gcloud module. We needed to add the gcloud module to the existing test container dependency. And as you can see here, that's Deshaun's native image builder that Dan mentioned. And then we just bumped some versions. So really the main difference was the addition of the gcloud module, and I'll be walking through how that, how you could run that and what it actually gets you. So if you're not familiar with test containers, they're made by Atomic Jar, and they're an excellent service that allows you to spin up like a short-lived ephemeral container that lets you test several backing services. So it could be a database, it could be anything that you can put into a container that is a meaningful dependency for your app. And so in this case, what the gcloud module provides is emulators that run locally that mimic the behavior of several gcloud services. There's one for Firestore, there's one for several services. And so this allows us to make sure that this gives us confidence that our app will be writing to Firestore as we expect it to before we deploy and actually start editing.
No question from the chat. The question for me, did I hear you right? That you're giving us emulators that we can run locally that are going to mimic Google Cloud? Is that what I heard?
That's correct. And actually a lot of them are community contributed. So it's been a really collaborative effort. But yeah, that's the idea.
Amazing. Where would I find a list of those?
Sure. Yeah. So on the test containers site, there's actually a gcloud module section.
So good.
Where you can see Bigtable, Datastore, Firestore, Spanner, PubSub.
I will put that link in the chat. Thank you so much.
Yeah, no worries. And yeah, I think I'll get into actually running the test. So there are a number of ways you can approach this. The easiest way is to bring in the Spring Boot starter parent, which this project already has. And what that affords you is a couple profiles, one profile and one execution goal that is already conveniently pre-configured for you. So if you scroll down, what I did is just shift or command click into the Spring Boot starter parent to see what the POM actually brings in for me. And if I scroll down to the plugins or to the profiles section, I can see that there are two important profiles. There are two important configurations here. There's native test, which is there's native test, which configures, which allows me to actually run my tests with like the native compilation enabled. And then there's process test AOT. And if you for some reason did not want Spring Boot starter parent in your effective POM, you can go without that. As long as you have these two configurations in there, you can kind of roll it yourself. But for our purposes, running the Spring Boot native test is a convenient profile, allows us to minimize custom configuration. But first, let's run the test in the non-native on the JVM environment. So we'll just start with the Maven test. I'm in the right folder, yes. What this does is I have Docker desktop running. It spins up a container, which you should see here in the log soon, that brings up the Firestore emulator. And let me go to the test so I can show you the configuration. Brings up the Firestore emulator and says, for my host, I'm going to get a randomly generated emulator endpoint. I'm going to use the no credentials provider, and I'm going to use a fake test project ID. If you don't have these configurations present, it will try to use the application default credentials and actually hit the project that it finds credentials for. So that's not what you want to do. That's going to result in a CI/CD failure if you end up pushing it. and it's not going to be a very helpful local test. But if you configure it to run in a faked out emulator, you still get the functionality without having to mess with service accounts or anything like that. So what we should see here is that our test succeeded, and it's the image analysis application container tests, and it is the specifically the, which one was it? Test event repository store image. That fail? Oh no, that's an earlier run. I'm having trouble reading the logs when it's this big, but I believe that the test succeeded. Yeah, it's in the right service, and it says test run 1. So I believe that we ran it. It's a very simple test. Essentially, we just run the event service to store a fake image with a fake label and assert that it actually gets an update time to show that the write was successful. And so if you wanted to, you could flesh this out with more and more tests. You could test the transactions work properly, things like that. But for our purposes, this gets the point across. And now if we wanted to, so that's all fine and dandy if you want to run the test against the JVM, but it doesn't guarantee that it'll behave the same way when you run it natively. So
I have one question before I let you move on.
It's
here. Is the Firestore emulator emulating GCP, or what does it emulate? It's just the service, right?
Yeah, good question. It is just the service. So it's not emulating all of Google Cloud. It's really just emulating how Firestore will respond to your client library calls.
Good question, Jürgen. Thank you.
Are there any more? We could. This is a kind of good breaking point before we go on to the native run.
After the build using this libraries and others like JPA, etc., one thing that they're worrying about is the size of the package. But I think you're about to address that. That's one of the benefits that we get from the native image. So
yeah, that is a good point. You know, it does seem like we're adding a lot of dependencies, but in reality, when you get through the whole build process, which it does take quite a bit longer, takes quite a bit more resources, but the resulting image size is much smaller than any jar you'd normally be pushing around, because it's really just the statically or the natively compiled binary for a specific architecture. It's going to be much smaller, start up much faster, require less resources than your traditional JVM app.
There's one more question, but I'm going to have Nikhil explaining Python virtual machine versus Java virtual machine. I'm going to have Nikhil, I'm going to have you wait just for the amount of time. Bring that to spring office hours. That'll come up here in about an hour. Look for that. Thanks.
Okay. So yes, if we want to make sure that this runs against the the native version of this test runs, what we have to do is enable the native test profile that we saw in the POM earlier, in the Spring Boot starter parent POM, which will tell JUnit to compile a native version of the app first and then run our tests. And lead to some differences. And I don't know if you have seen any of our other content about native image compilation, but we've talked about how it's you are paying up front for performance down the line, right? It does take a little bit longer, takes a bit more RAM, and if you, depending on the compiler and the garbage collector you're using, having a much bigger build machine can save you a lot of time, because with one of the garbage collectors, it will kind of stop the world when it's clearing, when it's garbage collecting, and that will severely slow down your build process. So this may actually take a few minutes, and this might be a good time to answer more questions. Oh, one more thing I want to address before I move on is the version of the emulator that you use. So you in the test here, we configured the Firestore emulator, and we basically just pass in a Docker image name to say what we want the container that we spin up to contain. And just as a developer, I find this is what I find so impressive about test containers. You can really stick anything you want in this container and know that your app is behaving exactly how you want it to with this dependency behind it. But in this case, it is a Google provided Cloud SDK emulator package that will allow you to run the Cloud SDK locally.
I've been in the same spot where the Graal VM processing takes a while. That AOT processing takes a little while. And doing it in front of an audience, sometimes it seems like it goes even slower when we're streaming everything. And because you've already brought up test containers, I'm going to give you a little trick that we can talk about offline. You can use these test containers to kind of build out your container and test it. Do that. It's a create the image, an image future. Right. So I can, hey, create the image, and then I can actually test that built image before I validate it and going forward. Just something fun we can talk about offline.
Yeah, I think I've read about that, but yeah, we should definitely talk about it.
Wonderful.
Yes. So I'm happy to take more questions. This build likely will take a while.
Yeah, there's no more questions. So can you tell me a little bit about what is your process? One of the things that I've been telling people, I'm just going to validate. I've been telling people this isn't really what you want to be doing in your inner loop development. You don't want to be creating these images and testing these images very often. Do your testing, your inner loop development against the JVM. And then do you have like a phase? Do you have a name for that? Maybe I should bring Dan on too. Do you have a phase for that point where, hey, I'm done doing my testing in the JVM. I think I'm ready to move on, but here's where I want to validate my native image. When do you do that?
We do that in, we have our build service is called Cloud Build. There are other build services. You can do that. We are always open to our customers using the tooling they want. We think that Cloud Build is the best for our cloud. So as you build, you mentioned you build your application, you will build your, run your test. You want to build your native image as well as your native tests in an integration, in a Cloud Build process, and run your integration tests as well. Because as we know, with the 12, now 15 factors application, development production parity, now called environment parity, is paramount in the cloud. And several of our customers have done this at scale. One customer runs like 200 pipelines where they run testing, integration testing, build, and multiple types of images all in one.
You bring up another point. Are you validating the multiple architecture OS combinations in your pipelines as well? Like I'm delivering my app. I use the multi-architecture builder, and then I want to deliver that native image. Are you validating each of those images that you might push out? An ARM64 image, an AMD 64 image. Are you doing that separately as well?
There are things which we do internally for our own libraries, and things which we advise our customers of how to test that. How customers proceed and do that in the end is their own, within their own realm of possibilities. We test our images on multiple architectures.
Mm-hmm. And just one more thing I want to add about the inner loop is the ability, especially with Graal, to configure the optimization level of your native image compilation, because can't you turn it down and have like a less optimized version that builds faster but still get some of the native optimizations in there for the sake of a test. That may save time in your loop.
That's a big part of Project Galahad, I believe, right? Where you can kind of decide how much ahead of time processing you want. That's something down the road from the OpenJDK team. But yeah, excellent stuff. We do have one more question from the group. This is from Fuel Snable, a regular. My inner loop is waiting for CloudFormation to build up my cluster, and then something weird happens and I get to start again 30 minutes later. Thank you for that. Thank you for that. We get it. All right. Looks like our build, I can tell that our build is close to wrapping up.
Getting close, yeah.
What else is top of mind? If I'm just joining the show, what should I be thinking right now?
Well, this is a native image build in action. As I said, it does take a few more resources, but it's worth it for the performance in the end. and this is best on a larger build machine, which, yeah, actually, with the rise of virtualized development environments, it'll be easier to get a larger build machine, even if you just want to use it for this the native image build part of your inner loop. That might be an option.
Yeah. Anytime I find myself doing the native compile locally, I always ask myself, hey, is there anybody watching? Because if there's not, I don't need to do it locally. I want that running in a pipeline. I want something else handling that because, yeah, that time is precious.
That's
right?
fair.
We're worried about, how many seconds it's going to start up. Well, of course, you should be worried about a process like this because, yeah, it can take a while.
We're also advising our customers when they build their Spring application and they containerize it to always think about this sum of optimization factors. Nothing like everything works as a collaboration. We collaborate on different things. We collaborate with other partners, customers. That's the same as when we build an application. We always advise them, look at your application, look at the environment, look at the runtime, and always think, what are you optimizing for? Do I need the sub-second startup time? Or do I just have to have my function or my containerized service built quickly and then I can use CPU boost? Is that sufficient for me to get, because time to market is paramount in the cloud. Then I can set things up. It's always in any Gregor Hope in his talks about integration architecture has this nice diagram with all those pencils from white to black, and they're different shades. Whatever we do, whether it's architecture or application design, it is in the end gray. The truth is in between. But we want to know what we need to look for, what we want to do, and which area do we want to, what is important to us, or what is important to us right now.
So good. That's important. What is important to us right now? That's a good question to ask. Excellent. Yep. I'm doing a lot of exploring on this multi-architecture path to production. We talked about the multi-architecture build pack, and one of those things I'm doing now is in my pipelines, in my supply chain. I'm building multiple images, and then I'm slapping those images back into a multi-architecture file so that no matter where that artifact or that service lands on whatever supported architecture combination with the OS, then I'm in a good spot because I also care about my development teams. There's a lot of my developers that are using Darwin on M1, and I want to be able to support them as well. So yeah, getting those different releases that I want to be supporting out, that's an important part of what we're doing.
And people build on multiple environments. I'm running a MacBook with an M1 processor. I also run it on an Intel, but now I have a cloud workstation available in the Google Cloud, which runs on Linux. Can I just continue my development, pass on to cloud build? Here's a cloud build file. Please build this image for me, run my integration tests while I continue to do my work, and let Cloud Workstation build, if I want my other image, run an entire set of tests if I'd like to build an image, put it in artifact registry, for example. Yeah. So the flexibility we have today is something we didn't have 5-10 years ago, when we have 3 screens and there's 3 machines. And we can look at different architectures at the same time while looking at the same screen.
Yeah.
And speaking of the quality of life and benefit for the developer that's enabled by like a cloud workstation situation, rather than having one heavy MacBook that is huffing and puffing trying to build an image like this, I can instead have a Chromebook and I can do my heavy builds in the cloud. I can do a couple things locally, but really I can know that I'm just using like panes of glass to do most of my development.
Yeah.
And I think that's where I'm going to be moving in the near future. Not quite there yet, but I think that's the way I'm going to go. Yeah.
Very good. I thought that we were further along. I thought we were on 3.7, and that's okay. This process, it takes a while. And yeah, the having different machines. One of the other things that I'm hearing a little bit, it's one of the things I'm pretty excited about is if I'm generating native images, wherever they're being generated, that's something that's smaller that I can pass out to the rest of my team. It wasn't, or maybe I'm aging myself, but it seems like there was a time not too long ago where I was worried about, is my jar file going to run on this JVM the same way it does on that JVM? Our data centers were massive, and we had to figure out which machines had the latest JVM. So there was that balance. And I feel like what we're doing now with the GraalVM native images is very similar to what we were doing, I'll say 20 years ago, with, can my jar file actually run on these other JVMs?
Yeah. Well, I don't think you're dating yourself that much. Like I was doing work just like that. Like you were saying, there's app modernization work, enough app modernization work to put us all into retirement, right? I was doing work like that 2 years ago. So yeah, I think that'll continue to be a reality.
Plus, having the ability to put now native images in a container.
Yes.
The container is our deployment unit of deployment. Do I want to run it in GKE and Kubernetes? Great. Do I want to run it in Cloud Run or in Cloud Functions v2? What do I have? It's a container. That container will do my work. Jarvan's hot tech, yes.
Yep. Yes. Wonderful. Yeah, this idea that these native images, they're smaller, I can pass them out, they start up faster. Whether or not they are going to give me the performance that the JVM does, the just-in-time compiling does, there's a big value for me, and I think for a lot of our community, where generating those native images for development purposes is going to be valuable, right? If the three of us are working on something, hey, here's the latest version of my user service. If I send you a native image that you can run on your M1 or on your x86, that would be wonderful, right? It's smaller. We could stay current quickly, and the cost of passing around those native images is much less.
Mm-hmm.
If you have to deploy to 3,000 edge locations, then this is where you go. Do you want to also leverage some libraries with Graal? You can develop in Python and in Java, have polyglot programming become a reality, because in the end, you're building towards the same native image. And that brings in a lot more in terms of shareability, or it brings it to a different level, which in the past, there was the Java world, there was the Python world, or I don't know, the Ruby world. Right. Now you can interop.
Mm-hmm. That's one thing that I don't think a lot of people understand quite yet. They're like, oh, you can't do serverless with Java. They haven't quite heard what we're talking about here right now, right? That's, oh, no, it's got to be a Node or it's got to be a Python. This is it. We're going to see here shortly that what we can do is we can deliver the type of startup times and the type of performance for a lot of use cases that rivals or betters some of what you see with these other languages.
Yeah.
There's a question if there's any configuration in the application to use that. To build native images, your application, let's say, like, again, the gray. I'm not wearing a gray t-shirt, but the gray. An application, the goal is, and for Spring and the Spring effort, is to allow you to build your application unchanged. And anything you would, if you were to add things which are specific to native images, like reflection or proxying and so on, you would do that in metadata, which now is being shared in a shared repository. But your application itself should remain unchanged.
For Spring, in order to get the benefits of the GraalVM native images, you should be upgrading to Spring Boot 3. Spring Framework 6 and Spring Boot 3. That's where it comes out of the box in the parent POM, like Aaron showed earlier. The Spring native dependency that was usable with Spring 2.x is deprecated. All the things that we got from Spring Native are now available in Spring Framework 6, Spring Boot 3, and the Google Cloud libraries.
Very exciting. And actually, you mentioning Spring Framework reminds me of, I think I saw a question around naming from Anbu. Yes, he says, recently Spring Cloud GCP is renamed to Spring Framework on Google Cloud. These days, Spring Framework means core. So can we rename it to Spring for Google Cloud? I think this is good feedback. There is a bit of like, picking apart that's needed for people who are somewhat familiar with Spring. So maybe that's causing confusion. But Yes, that is a rebrand that we've taken on recently. I actually just wrote an announcement blog post about Spring Framework on Google Cloud 4.0 coming out, and we migrated a polyglot sample app called Bank of Anthos over to use it. But yes, I think I'll talk to the product team about that, and that's something to consider for sure.
Excellent. Yeah, thank you. Wonderful. How's it looking? We got to be getting close.
Right there. Yep, 6 out of 7.
6 out of 7.
Yeah, I really hope that we have about 4 minutes left, right?
We have more than that. Like we can take extra time if we need to.
Good.
We want to see the end. We want to see the
after. Yeah, I do want to see the payoff here.
What else is top of mind when I think of these native images?
Well, configuration of your dev environment can be a bit of a hurdle. You may need to, depending on what your OS is and what your normal JDK is, you may need to install a specific version of Graal. You may need to install the native image tool. And those are tasks that can kind of be rolled into one pre-built image if you make use of something like cloud workstations, like Dan was mentioning. That's another kind of check in the column of moving to a virtualized workspace where everybody can just spin up an exactly identical container and get going testing something, rather than having to painfully set up and onboard every new developer to be able to work with the JVM apps and the native apps and everything else.
We've got a couple of good questions here. Apart from the startup time, is there any more benefits using native apps instead of a fat jar with a JVM image?
Outside of the fat jar, it's the startup. The startup time. Did I get the question right?
Yeah.
Yes. Any more instead of fat jar? Yes, you're going to have a smaller image, because the image will know at image build time what goes into the image. What is there is what you will get in that particular image. It will take, imagine that, like only what you need exactly to run your application. The response time of the first request is the same as the response of number 1000 or 2000. Over time, we can discuss hotspot and optimization and Graal, the different flavors of Graal community versus enterprise. But the size of your application is significantly smaller. For example, one of the samples I'm building for a project, and I use the Sean's image, is 3 times smaller in the native application than the JVM one. And it uses Firestore and PubSub, for example. It's a separate service.
Yep. So to address the question, is Graal VM required? Yes. What is a license? You just mentioned there's a community license that is available for use, and there's also a commercial or enterprise license, I believe they call it, to answer a couple of those. And Simon says, yep, regarding the desktop development environment as a Windows user, it certainly seems a bit more of a task than on OS X cloud workstations. It is, but the OpenJDK is now making it so you don't have to install the native image components separately. I think that release came out where now the Graal VM native image is a part of the community edition, is included with the OpenJDK.
Is it not coming out March 30th or 20th? It's
right around the corner.
Yes, it's with a new Graal VM image, and you don't have to run the native image.
Yeah. Let's see what else. Yeah, it's probably a good idea to have some native image on your CV. But how can I know? How can I know what you need when you have reflection in Java? It seems to my uninformed mind that it has to assume worst case everything is needed. That's the magic of the Graal VM, right? It's doing that. It's looking at every possible path that code can go. And if you've included a dependency for some other Postgres, and you're not using Postgres anyways, the Graal VM is going to throw that away. It optimizes down to what it needs. And that's the benefit. That's the magic of the Graal VM.
If you want to see that in action, you can run a tracing agent offered by Grout, and it will analyze your application. You can see its deduction logic. Spring takes it one level higher and makes it much simpler for you. You don't have to run configure a tracing agent. You just run with Spring. And if you are missing, the good thing is, and I like that when it was Spring Native like 2 years ago, when you ran the image and you had a failure because something got missed, and nothing is perfect in this world, it would tell you right away, this is the why it fails. It would even give you add this class is missing, which makes it easier. As a developer, I want to focus on where I'm good at, building business logic in my organization, not as in, well, do I need to know every intricacy of native images?
Dan, how do you decide if I've got a bunch of applications and we're looking at this modernization path, how do you decide which apps are good candidates to maybe look at doing some native images for deployments to production? How do you decide? How do you make that call?
Well, the first thing we want to know, like with any discussion with customers, is what problem are you trying to solve? What is your pain point? The second thing is, what SLAs do you have? Because in the end, what matters is, what do I have to achieve again now or in the immediate term? If I have an application where all I need is my application is a set of instances, I don't care that much about how quickly it can scale up. I know what I'm there. In that case, I might not need it right now. And I might be happy with hotspot. If I'm running in serverless, I might add CPU boost or minimum instances or don't throttle CPUs or so on. However, if my application is absolutely dependent on having a particular start time, then native image is the discriminator. It is the single most important thing to bring it down to the sub-second. There, like CPUs is very helpful, and it helps you a lot with Spring applications, which use reflection quite a lot. However, in the end, the JVM, I can tune it only up to a point. And the last mile, so to say, I can achieve that only with the native image. So if I have, it very much depends on SLAs. It very much depends. That's what matters. What matters is what is a customer trying to build in with that dev team.
Mm-hmm. Yeah. Deals Nabel says, why has startup time suddenly become so important? I've been waiting 20 years for it. Why now? Why is startup time so important?
Well, it's important because it allows us to build different types of applications which we couldn't build in the past. I'm coming from, okay, I shouldn't mention it, app server days back in, yes, I was in BA in that time frame, and we had a cluster of WebLogics. And great, there was no issue of startup time. The idea of scalability in a Sun machine at that time was non-existent. We planned on things differently. There's a lot more information circulating at this time. That builds up, there's a lot more data traffic. That builds up new types of applications. We need to build them. There was nothing like a Vision API in the cloud where we want to check, like a good thing, check that an image is safe for publication, or it does not contain banned items or so on. That did not exist. How do there were no super sale companies like who need to scale up because there's a massive sale, I don't know, one day at lunchtime. These are the new things which we didn't even think about at that time because we just didn't, some things objectively we could not do, or there were no such applications at that time.
Yeah, modern deployment strategies. Serverless was not a thing back in 2003. Right there, that wasn't a concept yet that we were even discussing or even thinking about. What is the version minimum of Java to use those libraries?
Java 17.
Java 17.
Java 17, and we advise customers to just, even if they don't build for their Spring applications with Java native images, just move from 8 to 11 or from 11 to 17. Just the runtime improvements and the abilities you have. I'm not talking about syntactic sugar or so on. Runtime in production, what matters is how quickly can I do this? How quickly can I run this? You get freebies by just updating. And Spring Boot 3 took a very good approach. It is Java 17 and will support it from here on.
Like Dan said, just that one change can improve your cloud economics. You can get more done with the same code and the same deployment.
Yep. Fuel says, why not 17? It depends. I mean, if you're comfortable doing that, you can. It just depends on your application. Some applications can make that jump, no problem. Try it. And then if there's a problem, then go back to Java 11 and check it out. But yeah, just changing your JVM. I highly recommend anybody that's watching, at a minimum, upgrade to Java 17. Do yourself a favor. So we're waiting. This is awesome. Honestly, when I first started doing the native image compilations, I was doing it on a Raspberry Pi. I was trying to build on one of those little 8 gig devices, and I had builds that took 30 minutes. I don't think we're hitting that point yet, but that's one of those things. The Graal VM itself has also improved dramatically. We're doing a stream and you're doing stuff. So yeah, it's taking a little bit of that processor away from the Graal VM. I get it in there.
This is taking longer than in the tests. Yeah.
I've been there. I know your pain, and I feel for you. I'm a little sweaty because I have been in that seat. But I get it. And I remember back to the days where it was taking 30 minutes to do these builds. But the Graal VM has improved so much that normally it doesn't take this long. Like if I were to do one of these, one of my normal demos, 2-3 minutes is kind of typical for me. But yeah, we're doing
and the screen sharing on the Mac will sap up quite a bit of CPU.
Yeah,
that does take it. Yeah,
we'll let you finish up.
We saw
Take your time.
Sure,
we're not missing out on anything. I'll drop us off.
Okay. So we saw the produced artifacts there, and now it's actually running the native tests against those produced artifacts, the natively compiled version. And okay. We have a test failure. We have 2 containers found, 2 containers started, 2 containers. Okay, so it did run the test, but it failed. Okay.
And this is where I like to add. I learn more when the demos don't go as planned. I learn more. So now I'm interested to see, like, hey, so our thing failed. This is a reason why we don't want to do this in our inner loop development for this reason, right? If you were doing this on every change you made after you write all your test-driven documentation and your test-driven development, you're writing a test every time. But if you were to wait this long, or even 2 minutes in between each iteration, yeah, you're not doing yourself any favors.
Yeah, so, and it is also an example of like the test working on the JVM, but then not in the natively compiled version. So there is something here. It may actually. I am seeing a timeout exception. I wonder if that's
totally valid. Totally valid. We understand.
Yeah, that. But are we able to see the startup times for the app here? So you can see that it's running in the Cloud SDK emulators here, and we can see that the app started in 0.277 seconds when running these tests. As opposed to, I didn't check the time when we were running the JVM version.
It wasn't sub-second.
It definitely wasn't sub-second. It was 3.9 seconds earlier. So that's a factor of, I'm not sure, 20, something like that.
It's quite an improvement.
So once you have the native image built, it is a lot faster. But there are some considerations, and you have to make sure that it's worth your time to. What does started mean? That's a great question. It's worth your time to make sure that the test runs natively and on the JVM. I don't know if I'll be able to fix this one live, but we will have a link to the repo where
you know what. I do a show with my good friend Dan Vega. And for anybody, I'd like to invite you onto our show. I'd like to give us a chance to rerun this for anybody that wants to come see it. you come onto our show and we'll do it again. But this is a great question. What does started mean? We're planning on talking about that in our next show and in spring office hours. The difference between, hey, my app is up and my app is ready to take load, and answer requests.
Which lifecycle hook is it on? Is it actually up and healthy? There's a lot of that's not an obvious question. That's a good one.
Yeah, this is good stuff. When is it considered started? Yes, being up and being ready is two different things. But great question, great question, Aaron. I'm sorry that I didn't make my daily contributions to the demo gods for you, but this was a totally powerful. I'm going to switch us up here, and I'm going to switch us to this. Let's talk. Like, this has been great. It's been wonderful for me, and I've learned a lot. Some of your tricks there, how you're searching through your logs, like that's something that I haven't done, and I know I need to do. I need to figure that out. So this has been great. You guys, I really appreciate your time.
Thank you. Yeah, it's been a lot of fun.
And I definitely have some things that I'd like to try out. I put a link to the lab. I put that in the chat. And was there one more link? Oh, and I also did for the test containers modules. I put that in the chat as well. Any parting words? I have a couple of additional pieces I need to do here at the end, but any last words?
No, I think this has been great. Thank you for your time. It's been a great experience. This is a great technology to work with. Once you get through all the configuration, and it's getting easier all the time thanks to the hard work of people in the community like the Spring team, making the Spring Native project mainline. And yeah, I'm excited to see where it goes.
Dan?
Well, I want to echo, thank you for inviting us. What we would like is get the feedback from you trying it out. By try it out, build a code lab, try it in the Google Cloud, tinker with it, see how it runs, how it connects to different services. Instructions are all there. The free tier in the Google Cloud, if you're if you want to try it on your personal account, is more than sufficient for you to run this repeatedly. Try it out, and we learn as we go. We'd like to get your feedback. That is important to us.
And where should we send our feedback? Twitter?
Twitter, absolutely. Feel free to reach out on Twitter. Reach out or comment on YouTube or wherever you'd like. But Twitter is probably the fastest to get in touch with us. Excellent.
Some last comments. Hey, thanks for the great talk. Thanks for sharing your knowledge with us. I have a few things. Thank you guys again. Yeah, I'm excited. Aaron, I'm going to ask you to stay on the line. I am going to invite you to a little show if you've got time.
Yeah, I believe I do.
Thanks again. And for everybody else, I'd like to share, like, hey, this has been great. I'm going to hide this. I put up the wrong banner. We have a Spring Academy. If you're interested in learning about Spring, this is a great place to go. It's awesome. It's getting more and more content every day. So if you haven't checked it out, it's free. Make sure you check that out. And also, this is the golden path to Spring One. And I'm hoping to see you at Spring One. That's coming up here in August in Las Vegas. And you should register now. Don't meet me there. Beat me there. Thank you again, everybody. We'll see you soon.